Good afternoon. My name is Michael Stabile, and I'll be your host for today's session, Specifying an OT Network. Thank you for joining us for this fifth installment of our TridiumTalk Specifier series. Our earlier sessions, Niagara 101 for specifiers, crafting powerful Niagara specifications, writing cybersecure specifications for buildings, what you need to know, and writing analytic specifications for smart buildings were all recorded, just as today's session will be, and are available for playback on our website. Just one quick housekeeping item. If you'd like to ask any questions, there's a Q&A button on the bottom of your screen for you to enter them at any time. We may answer you immediately on the chat, but some of those questions we'll hold to answer live at the end of the session for everyone to hear. With that, it's my pleasure to introduce our presenter for today. Gregory Fitzpatrick, Business Development Manager, Cochrane Supply and Engineering. Prior to joining Cochrane, Greg was a commissioning manager and then executive director of physical plant operations and engineering for the Detroit Public Schools. And he's the owner of BDC Engineering, a full service building systems consulting firm specializing in building commissioning, retro commissioning, and facility management. Greg routinely presents workshops on various aspects of engineering and commissioning in his work at Cochrane, and we are grateful to have him with us today. Without further delay, here's Greg.
Thank you very much, Mike. I really appreciate the introduction. We're going to get right into it because we've got a ton of stuff to cover today, and we're going to do this sort of like speed dating. So when you leave this session, my hopes is that you understand the hardware and software solutions that are out there for an OT network. You understand what an OT network topology looks like, and you know exactly where to go to get some of your questions answered. This presentation is basically about how to get an OT network and all of its components in a set of plans and specifications, right? We want to be able to articulate our design intent and get it into a set of plans and specifications. So what we're going to cover today is IP devices, which is one of the driving forces as to why OT networks are emerging and prevalent right now. We're going to talk about exactly what an OT network is. Going to touch a little bit about cybersecurity and our approach to cybersecurity for OT, how to specify an OT network, select an OT network solution, and some of the fundamentals of designing an OT network. And if time permits, we're going to go through a brief example project. So, like I said, our industry is moving to IP devices, which has pushed our industry and our systems integrators and contractors to be more proficient when it comes to IP technology. And why are the vendors or manufacturers moving to this technology? It's simply because Ethernet moves more data. We're in the age of data analytics and things like that and running applications at the controller level. So what we need now for smart buildings are smarter controllers. And what's happened now is because we need IP switches and an IP network to support these controllers. That same IP network or OT network can also accommodate other technology in the building, which we'll get to here briefly. So what is OT? Most of you on the line probably know exactly what OT is, or you've heard of OT, but OT is operational technology. And what that is simply put, anything that's bolted to the building, right? We're all familiar with IT and what IT is, and OT is basically anything that's bolted to our buildings, like our HVAC systems, fire alarm systems, building access, and things like that, and lighting controls. So why do you want to separate the two? Well, the main driver would be the emergence of IP devices. But not only that, information technology, IT, and operational technology, they behave totally different. One is user-centric, one is machine-to-machine communication. And the other thing that's really, really important is that it's a lot more expensive to manage IT networks because of IT professionals that manage those networks, opposed to an OT network if you select the right solution, which should be pretty much designed for a facilities person to be able to operate and manage. So why is it important? Well, right now, we need capable designers and capable contractors, installers to be able to understand these OT networks because of the change in technology. But not only that, a lot of companies and owners are starting to get really, really savvy when it comes to cybersecurity. So separating the IT from the OT provides a more secure environment for a company's sensitive data, right? So if you're a consulting engineer and you're designing a building management system and you're connecting to the internet, there's immediate vulnerabilities that exist. Well, you will immediately be dragged into a lawsuit if, in fact, that system is compromised and the owner's sensitive data is compromised. So what's happening now is there's a huge push to separate IT from OT, and the consulting engineering community doesn't have any control over the owner's IT network. So what we're trying to do is separate the two and make sure that the information is out there so that the entire industry can become capable designers and installers of these OT networks. One of the first things I want to touch on briefly is cybersecurity for OT. Now, there's a huge push for cybersecurity and OT in the industrial space, but what we've done at Cochrane is simplified it, and we've taken a more basic approach to cybersecurity for OT, because cybersecurity has a ton of layers to it. You have to be a cybersecurity professional or an IT professional to understand those multiple layers of cybersecurity. But for us in the facilities world, to ensure that you have a safe environment for these IP controllers, we've broken it down into 4 areas. And one is encrypted data at the supervisor and the device level, managed IP switches opposed to unmanaged switches, a physical firewall, and a written cybersecurity policy. So we are talking about encrypted data. For those of you who have sat in on some of the other sessions, I'm sure that this was pretty much brought to your attention that Niagara has encrypted data both when it's sent and when it's received and at rest, right? So the JACE 8000 or the Niagara supervisor meets all those federal standards for cybersecurity, and it meets encryption standards for anything on the industrial side when it comes to mission critical industries, right? But when you take it a step further and you start looking at a solution for the network itself, the hardware and the software for the network, you want to choose a solution that's going to have managed IP switches, right? Or managed edge switches. And what that allows you to do is a few different things, and we'll dig into some of those things and some of those features that you're going to look at when you're selecting an OT network solution. And then a physical firewall. We all understand what a firewall is, and this is where you're going to be able to set up all your security rules, and it establishes, a wall between what you want on your network and what you don't want on your network. And then the last is a written cybersecurity policy. Now, as a consulting engineer, you may say to yourself, well, what risk do I assume if I write a cybersecurity policy? Well, for the engineering community, this isn't something that you really want to get into, but this is something that you definitely want to recommend to the end user. Most companies hire IT professionals or third-party professionals, or if they have a large IT department, they will write their own cybersecurity policy. And it covers things like authentication, user removal, audits, backup, things like that, disaster recovery and all that good stuff. So you want to make sure that you've got a cybersecurity policy in place also. So those are the 4 areas that if you cover those 4 areas while designing and specifying an OT network, you will definitely have a secure network. So let's talk about the OT network itself. So when I was a consulting engineer for years, it was difficult getting your arms around the controls industry, right? A lot of engineering firms treat controls like fire protection, right? They're going to write a performance spec, they're going to send it out there and let the contractor or the systems integrator pretty much be responsible for making it all work. Well, that's not a good solution when you're trying to design open systems. And, our approach is agnostic, right? We want to make sure that this approach applies to any and every manufacturer out there that meets the specification. So when you're looking at an OT network solution. When I say the OT network, that's comprised of the management switch, the fiber, the edge switches, all that good stuff, right? You want to look for something that's easy to design, install, and manage, right? And when I say manage, we're talking management from the facilities department or an outside integrator as a service contract. You want something that's going to be scalable. You don't want something, as I said before, that has managed switches, features like port security, VLAN capabilities, and things like that. And you also want to make sure that you select a solution that has a graphical user interface. And why a graphical user interface is because that's what facilities people are used to looking at with their building management system, right? So facilities professionals, they're used to pulling up their system through a graphical user interface and seeing pretty pictures that lets them know exactly what their system is doing. Well, there are solutions out there for OT networks that have the same features where you can pull up a graphical user interface and you can look at the switches, you can look at the ports, you can look at the bandwidth, you can open and close ports, you can secure the entire network. Those solutions are out there. So if you're a designer or you're an integrator who's just getting into deploying IP devices for your customers because you want to future-proof your owners, your customers' buildings, then these are some of the things you're going to want to look at when selecting the solution or considering the solution. So what I wanted to do here is give you guys a bunch of pretty pictures because, you know, if we've got a ton of engineers on the line, I know from my consulting days and most of the people I talk to, pictures say 1,000 words. And at the end of the day, you want to make sure you can get as much on the drawings as humanly possible and make sure that your specifications are ironclad. Well, in doing this, one thing I wanted to do is show you guys exactly what the hardware looks like, what a topology drawing looks like, so that you can envision a modular approach to a project, okay? So when you're looking at designing and putting together an OT network, you're gonna want somewhere to house the hardware, okay? So you're gonna need a server rack or a control cabinet. Now, what I'm gonna show you here is for a self-contained IT network or OT network that's not connected to the internet, that has its own server and is totally separate from IT. So for this example, this is what you would be looking at. You'll be looking at a server. You need your integration software, what we like to call it. A lot of engineers still call it the front-end software. Our software of choice is, of course, Niagara for Tridium's Niagara. You're going to need a solution that has a network management switch with a graphical user interface, like I mentioned before. Then you're going to need the network media. Now, like I said, our industry is moving to IP devices, which requires Cat6 cabling, right? So they're networked together. These controllers are networked together with Cat6 opposed to backnet MSTP devices, which are being slowly but surely phased out, which use 485 cabling, right? Like I said before, Ethernet moves more data. So if we're talking about smart buildings, then we're talking future-proofing your customers' buildings, we're talking about IP technology. So you're gonna need to choose your media network, and those switches also will use either fiber or Cat6 cabling. Then you're gonna have your edge switches. I mentioned the physical firewall. It's always good to consider a wireless access point so that a contractor or the owner can jump onto the network, the OT network, wirelessly, right? Then you're gonna have a layer 3 router. We'll talk about all these components, a power distribution unit and a UPS. So you envision a project, you go to the architect, you say, hey, I've got this OT network rack that I want to locate somewhere. The owner's gonna decide whether it's gonna be in the IT MDF or one of the IDF closets, or is it going to be in a facility space? We always recommend a facility space, but this is where your network management switch, your server, your router, your firewall, power distribution unit, and UPS are going to be located all within this cabinet. So now you've got a cabinet with a bunch of components. You'll be able to specify a cabinet. The architect will know the weight of the cabinet, the size of the cabinet, so we'll know where this cabinet will fit. But it's important to show all this stuff on your drawings. And I'm going to show you the drawings that we've been promoting to the engineering community called a systems integration drawing, right? And it's a little more detailed than your typical systems architecture drawing that you're typically used to putting out there in your controls drawings. But what this would do is give the contractor or the systems integrator a pictorial representation of your design intent, and they can look at it for 2 or 3 minutes and know exactly what your intent is. So let's talk about all those components I just ran over. The integration software, like I said, Tridium's Niagara 4. This is where all your equipment scheduling, your alarms, trending, graphics for all the systems that are being integrated. So your master systems integrator is going to develop all the graphics for all the integrated systems from this software, right? Any dashboards that C-level, that people in the C-suite may need, any edge applications, all this stuff will be ran right here from Tridium's Niagara 4. In addition to data tagging. The server, it implies exactly that. It's exactly that. It's a server where all the backup and storage is being done. It's going to run your integration software, your Niagara 4. Any other software or programming tools can reside on this server also, depending on how those tools are deployed. And you're going to want to have a distributor like ourselves help to size the server. So if you're a consulting engineer and you're laying out a job, we can give you a specification on a server that will run your application. And then the physical firewall, and we talked about this a little bit, but you want to make sure you have this appliance in the topology. And this is where all your security rules are going to be established. It's going to direct all your IP addresses and all that good stuff. A lot of these firewalls nowadays have optional VPN and cell modems also. So you can get an appliance like this that's not just the firewall, but it also has those other capabilities like VPN and cell modem. And then the power distribution unit, which is going to be in that cabinet to plug in all those components. We always recommend that you get something that's network graded, right? So that you can ping this power distribution unit remotely so that you can shut off any of these outlets if you want to restart a device, right? You want to recycle or reboot a device, you can do it remotely. So we always recommend that when you're specifying a power distribution unit for your rack, that you get something that's a network grade. And then a UPS, we all know what a UPS is. It's uninterruptible power protection for everything that's in that rack. And then the layer 3 router, and I'm going to show you this in the topology drawing here shortly, but the layer 3 router is actually where all your IP addresses are managed from all those IP devices, right? And this is where your VLANs, your virtual local area networks will be set up where you separate your technology or separate equipment on your network. And this is where you want to make sure that when you do select a solution, it's always best to select an OT network solution that has this router integrated into it. Even if it's a separate piece of equipment, you want to make sure that this router is integrated into that graphical user interface so that all of these functions, as far as VLAN management and IP address management, is being done right there from the graphical user interface. And then we talked a little bit about a wireless access point. That's another feature that when I'm assisting with designs, whether it's a systems integrator or a consulting engineer, I always tell them that you're going to want to specify a wireless access point. So when you look at the OT network as a package, it's a combination of the edge switches, the network media, which is going to be fiber or Cat6, a combination of those two or just all fiber, and the network management switches. Most of the solutions out there for managed solutions are anywhere between 4 and 48 ports. So when you look at some solutions, they're all built for OT. So if you're an engineering firm and you're laying out an OT network, or you want to go with what they call a flat architecture with all IP devices, all these IP devices need somewhere to land. And the owner's not going to give you, let's just say you've got a job relatively large size job that has over 500 controllers, then no one's going to give you 500 IP connections, right? Now, you may have some enterprise customers out there, like some of the auto industry and people like that with global IT groups who, purchase those large Cisco switches or HP switches with a ton of ports, and they've got a special deal with those guys, and they don't mind spending $30,000 on a switch. But for the facilities industry, it's best to get an OT network solution that's made for the facilities industry and priced for the facilities industry. So there's solutions out there that are priced accordingly. And the network these switches are anywhere from $1,000 to just a couple $1,000, if that. So the network media, how do we connect these switches and develop our topology? Like I said, we're getting away from 485, which is BACnet MSTP, and going to BACnet IP, which requires Ethernet. So the network media that's used to connect the switches is typically Cat6 single mode fiber, and in some cases multi-mode fiber. We always recommend a solution that uses single mode fiber because single mode fiber actually bends a lot more and it passes more data. Now, I talked a little bit about a graphical user interface. So when you're selecting an OT network and you've got this network management switch, which is quote unquote the front end for the OT network, and now you've got the other switches out in the system, you want to make sure there's a graphical user interface so that you can see what's going on with each switch. So in other words, if I plug in say an 8-port switch, I want to be able to view every port in a graphical user interface similar to what you're seeing on the screen now, and be able to do port management and port security, meaning anytime a device is plugged into that switch should lock in the MAC address for security reasons, and you should not be able to unplug that connection on that device and plug something else in there, right? So if there's open ports after the job is finished, say you have an 8-port switch, but you only use 7 ports on that floor of that switch, you should be able to lock that open port through the software. And if you needed additional security, you can always purchase port locks with a key to give you that extra bit of security. But you always want to make sure that you have that graphical user interface, or you're shooting in the dark as a facilities owner who's managing the network, or a systems integrator who may be managing this network. You want to be able to see every switch, every port. You want to be able to set up the VLANs. You want to separate technology. So if you've got an integration project with lighting controls, HVAC, security, and let's just say the generators are also integrated, then you've got 4 separate technologies there. You may want to separate all those technologies on the network and then go and set up sub VLANs within each technology, right? So the HVAC, you may want to separate all the air handlers from all of the AV boxes, or do it floor by floor. But you want those VLAN capabilities so that you're able to do that. And also, most of these solutions have PoE, which is power over Ethernet. So in other words, you can plug in a camera that requires power, but through that port, you're supplying both data and power. So if you don't have a solution that allows you to monitor the PoE for every switch, then the contractor's in the field just guessing. So when he plugs something in, it doesn't work. Maybe the switch ran out of PoE, but there's solutions out there where you can graphically see the PoE budget for each switch. And that goes the same for bandwidth monitoring for each segment. When you're building your topology and building out your project in the field, you want to be able to know exactly how much bandwidth you have on the entire system and in each segment. And a graphical user interface will allow you to do that. So I get this question quite a bit. I'm working with a ton of engineers across the country A lot of the larger firms, the first thing they ask is, where do I put the OT network in my specification? Now, there's several ways to skin a cat, and there's different schools of thought. And I've been a proponent of using Division 25, which is called integrated automation, right? But if you go to CSI and you pull up their boilerplate specification for integrated automation, most firms I've talked to, they look at it and it's section, subsection, subsection, subsection. And there's a lot of information in there that doesn't apply to a typical project and a typical project that they may be laying out. So what we've done is try to come up with a modular approach where Division 25 pretty much houses your OT network and all the technology that's involved in that, your front-end software, along with all the verbiage that directs the other divisions back to Division 25, integrated automation. So we typically like to tell our designers that, look, start developing your Division 25 specification. We've got guide specs out there. I'm working with a large firm right now to develop a Division 25 specification for their group. And it's a heavy lift to get something that applies to all projects. But at the end of the day, if you have Division 25 and you're used to working on projects that are multidiscipline, then that's the way to go, because now you can separate the quote unquote controls contractor from the master systems integrator. And your master systems integrator is like that extra level of commissioning to work on the owner's behalf, help them oversee the other contractors or other disciplines that are being or that are part of that integration process. So like I said, if you have a project where there's HVAC, lighting controls, security, then your master systems integrator is going to be a part of that commissioning process to make sure that their systems are up and running and that data or that data is available to be pushed up to that integration platform or pushed up to that web supervisor, right? Where we can start doing all of our scheduling, developing all of our graphics, and setting up all those functions that the owner needs. And now you've got two separate contractors there. So, if you look at the bottom right hand of this drawing here, this is a systems integration drawing. I've got other examples of it as we go through. But if you look at this systems integration drawing, it shows a detail of the cabinet. Off to the right, you see all those are our CYA notes, right? And then you see some of the front end network management switches, routers, VPN appliances, cell modems, firewalls, all that good stuff. But this gives a real good idea to a contractor of what the integration process is going to look like. So we've been recommending that every designer with a large integration project, make sure you put a systems integration drawing in your set of documents and use Division 25. And like I said before, the reason why you want to use it is so that you have an open platform, right? We don't want to sole source or sell proprietary systems to our customers, because what we're trying to do is future-proof our customers' buildings. So that starts from the integration platform. Your customer may not know what type of applications they want to use right now in their building, but if you have the right platform in place and an OT network in place, then it's easy to add those services, those applications at a later date. And like I said, your OT network, it's going to land in Division 25. Here's one of my sticking points. I've been a stickler when it comes to this, and a lot of smaller firms, and I've seen a lot of firms out there that throw that word Tridium around quite a bit, or Niagara around quite a bit. And we all understand that Niagara is a technology, right? Niagara shows up in a host of hardware solutions out there, right? There's a ton of manufacturers that uses the Niagara platform to drive their their controllers or their software. But what we like to do is explain that if you're talking about an open system, you're talking about three things: open technology, which would be Niagara. Niagara is like the Windows of building technology. You're talking open protocol, right? And BACnet is the cream of the crop. And we're talking that third one, which most people and most engineers don't really get, or they don't really think about, and that's open distribution. Meaning there is an entire marketplace where my project is being deployed. There's an entire marketplace who could purchase, install, program, commission, and maintain the hardware solutions that I'm specifying. So in other words, when you're specifying controllers, when you're specifying these other things, because there's a ton of systems integrators in every market who are Niagara certified, right? So someone from an equipment manufacturer may say, hey, we've got Niagara, we've got Tridium's Niagara, and we've got BACnet, we're open. Well, there's only one office in that industry or in that marketplace that can purchase that software or that hardware and program it and maintain it. So what we've been doing is pushing out the narrative to let all the engineers know that you have to select best in breed products that apply to those three pillars, not just two, but all three. If you have all three, then you've given your customer an open system, right? And Division 25 will allow you to set up that platform to do that. So if you're an engineering firm and you're asking yourself, well, that's a pretty heavy lift. We don't use Division 25. Our staff is multidisciplined. I'm not sure if we have the time to even go down this road. Well, what I've told most firms is that what you want to do is look at projects in an individual manner. For instance, this is a project that was a school district that had middle schools, I think 3 middle schools, 2 high schools, and a few elementaries. They wanted, most school projects are phased out. They wanted to do 2 of these middle schools, but they wanted to make sure that, of course, every school from a graphical user interface looked the same. So how do you do that if you're going to have multiple projects, right? And still create a competitive bidding situation? Well, this is a perfect example of where you use Division 25. So this is an actual project. This is a drawing that I did for a customer where they had 2 middle schools, but they wanted to hire a master systems integrator for the district. Well, a master systems integrator, because they're not actually installing and purchasing anything for the most part, right? That can be a consulting contract. And a lot of school districts will let the district hire consultants through an RFQ, request for qualifications, right? And then we assist a lot of customers out there in writing RFQs, writing RFPs, recommending the right partners, the right systems integrators, and the right master systems integrators, and a lot of markets across the country. So here, the master systems integrator was hired to do all the work at the top of this dotted line, right below the school district wide area network. The master systems integrator was hired to do all of that work. And that was put in Division 25. And then Division 23, your typical Division 23 900, where your controls contractor or systems integrator would bid, they would bid those projects out individually in their own bid packs. And I think these 2 schools actually had 2 different contractors, but because there's a master systems integrator adhering to Division 25, all the graphics, all the tagging, all the scheduling, all that stuff, the alarm strategies, all that stuff is common from building to building. So that's one of the advantages of using Division 25 also. So one of the things, I ran a consulting engineering firm for some years, and one of the things that I thought is that, hey, if I was implementing this technology to my office and I wanted to make sure that there wasn't a huge learning curve and it burned up a lot of my principals' time and things like that, one thing I did realize is that a lot of the younger engineers out there are being driven to our industry because of the technology, right? Because of the technology, because of all the cool applications they're starting to see. I just did a presentation at Lawrence Technical Institute, and that's what I'm getting from them. So my advice would be is to hire take someone in the firm and make them the technology coordinator. That would be the first thing I would do. One of the next things I would do is develop a topology of the IoT platform or the systems being integrated on a project. So we're thinking on a project basis right now. So I would develop a topology, a systems integration drawing, so I would know exactly what's being integrated. Then I would develop an integration matrix that would actually go on that systems integration drawing. And then I would get every discipline that's involved in the integration process. So in other words, if I have a multidiscipline A&E firm that has both architectural and engineering, but we have every discipline that's going to be involved in that integration at our office, then we would have team meetings and make sure that everyone has something in the front end of their specification. So the lighting controls if the lighting controls are being integrated, I would make sure that Division 26 has something that points that contractor back to Division 25, so they would understand their roles and responsibilities to the Division 25 contractor, okay? Then I would coordinate and make sure that all this stuff is reviewed with all the parties involved and use that process as a starting point to be able to put out a set of plans and specifications without being spooked that you're going to get a bunch of submittal drawings back that you don't understand. So when you assign a technology coordinator, they're going to make sure that they develop the checklist for all the things that need to be coordinated. They're going to develop the integration matrix. They're going to make sure that the specification verbiage and the drawing notes for all those systems being integrated are in that section or in that Division 25. But in addition, there's going to be notes at the front end of each integrated discipline, right? This is what an integration matrix would look like. And I would advise that this matrix be put on every drawing where there's a large enough integration. So if you're integrating more than 2 disciplines, I would definitely put together a systems integration drawing. And if you're deploying an OT network or designing an OT network, I would definitely do a systems integration drawing. This is one of the things that I will put on there as an integration matrix. And remember, you're going to point everyone that's involved or every discipline that's involved in the integration process, you're going to point them back to that systems integration drawing, and you're going to point them back to Division 25. So they know their role and responsibility. And you can see there's just some general notes here. But remember, as a consulting engineer, we want to make sure we get as much on the drawings as humanly possible. So there's no way that the lighting control contractor, the fire alarm contractor, the contractor handling the escalators or the HVAC, none of them can claim that they didn't know that they had a responsibility for providing their data to the master systems integrator. Because if they didn't open up the specification, at the very least, their drawings and the front page of their specification will point them back to this drawing. So we want to make sure that we put as much on the drawings as humanly possible. So when you look at an OT network, here's a really good example of a systems integration drawing. Off to the left, you see what we like to call the integration platform components, or the front end components, as we like to call them. Like I said before, your OT network MDF is here. So now the contractor knows exactly what size this cabinet needs to be. So these cabinets, they come as 4U, 6U, 8U, 10U, 12U. So if you count the components here, the contractor knows exactly what size cabinet he needs to get. And if some of those components change during the submittal process, he still would know exactly what size that cabinet needs to be. And he knows that he has to supply this cabinet, right? Off to the right, you see the edge switches, and then everything that's being integrated. In this particular example, there's some metering, emergency generators, and I think lighting controls. And this is in a flat architecture because you can see the Vicon Jace off to the right here. So these OT networks can accommodate a combination of a flat architecture, which will be all IP devices, or a combination of both BACnet, MSTP, Modbus. All different technologies and protocols can be actually integrated into this OT network. So I want to run through a really, really brief example of the concept of how you would begin a design, right? How would you lay out a project? So one thing I would do is start off with a design development or discovery phase, right? So we're going to want to know from the architect or whoever's involved who's going to make that decision, where will my server rack be located, okay? Next, you're going to want to know what technology is going to be integrated into the OT network. Is it just HVAC and lighting controls, or are there other technologies that are going to be integrated, right? Then you're going to want to know what protocols are these technologies using, which will in turn let you know what those subnetwork media will be, right? So if we're using BACnet IP, we know that's Cat5 or Cat6. BACnet MSTP, we know that's 485. Modbus, RS4. We know based on the protocols and the technologies, right? We're going to want to know, is there a connection to the internet? So if there's a connection to the internet, now a whole new can of worms has been opened. Now we need to make sure that we've got a firewall installed. If we want remote access, now we know that we need a VPN appliance, right? So those things are gonna, you're gonna wanna know those things early on. You're gonna wanna help your client make those decisions early on so that you know what you're up against when it comes to the design. Then you're gonna wanna know if there's any future plans for expansion later. And that's going to let you know exactly what that systems integration drawing should look like. So let's just run through this example project real briefly here. And this was an actual project from a healthcare provider. And it was a multi-story building, 5 stories, no connection to the internet. It was an on-prem server that's going to be rack mounted. And we were using Tridium's Niagara 4, of course. And like I said, it's standalone, its own server, and it's totally air-gapped from the owner's IT network. So there's no connection whatsoever. And we weren't concerned about cybersecurity to that extent because we weren't connecting to the internet. And if you look here at the bottom, these are the 4 technologies that were actually being integrated: HVAC, emergency generators, fire alarm, and lighting controls. So this segment drawing shows you basically the front end, okay? This is a small segment of the systems integration drawing that was put together, and it shows you the front end. Because it was a healthcare facility, they wanted redundant network management switches. So you see the green boxes here, this hardware, these are network management switches for the OT network. And then you see the layer 3 router that we talked about. We talked about the router a little earlier, where all your IP addresses and VLAN capabilities are done. And you see off here to the left, Tridium's Niagara is being installed on this server. There's no instance of it in the cloud or anything like that. There's a 4-port edge switch here because they wanted multiple on-site operator workstations that they can just hardwire a connection to. So we gave them a 4-port switch and a wireless access point there. The yellow lines represent fiber. This plastic box here is a typical splitter. So this is a splitter, the one solution that we push out there to the industry They use passive splitters to split the light, gives them an opportunity to have a really, really flexible topology, when you're laying out systems. And those things are about the size of an iPhone. They're plastic and glass, nothing else. Some people use Velcro to tape them to junction boxes and things like that. So this is what the integration platform or the front end would look like. Here's an up close look at that OT network MDF, we like to call it. And here you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 components there. I would show this on my systems integration drawing if I'm an engineer, because it lets the contractor know that this is all the hardware that's going to be installed in this cabinet. You're responsible for looking at that hardware, determining the size of it, and getting a cabinet that accommodates all that hardware, right? And the good thing about it is that as an engineer, you can look at this early on, and let's just say this is a 10U cabinet. Well, you may want to go and look at the cut sheet for a 12U cabinet and tell the architect, this is how much size space that I need, and here's how much it weighs, right? If a 10U cabinet is selected and it can accommodate everything, then you're doing great. It's a little smaller, it's a little lighter. So I would start off really quick with a what I like to call an integration schedule, right? And for every floor, this is a 5-floor building. I'm just going to run through the first floor real quick. Every floor, you're going to list the equipment. You're going to show the controller locations, the communication protocol, like I said, the subnetwork media, and the quantities. And this is what it would look like. So here's the first floor for the example that I'm showing you. And this is the integration schedule. So I would actually go through this exercise on every large integration project that I have. So on the first floor, the emergency generators are outside, a fire alarm, a panel, there's HV unit, lighting controllers, VAV boxes, and a whole lot of other terminal type devices. Then you look to the center, the middle column here, excuse me, then you have the protocol. What this protocol does is lets us know the network media. And then you put the controller quantity. So why is all this important? Well, because you're trying to build this type of drawing for your systems integration drawing. So this would be the first floor. So these blue lines represent 485 cabling. I'm sorry, represent Cat6 Ethernet cabling, right? The purple lines are 485. So when you look here, you see we've got an 8-port switch here. So you've got 1, 2, 3, 4, 5, 6 connections, 6 Ethernet connections going into an 8-port switch. So you will have 2 ports, spare ports for future integration or to add equipment or something, anything that you like to do with those ports, or they just may be spare ports, right? When the contractor is off the job, systems integrator is off the job, you lock those ports through the software. Me personally, I would add port locks also. But if you look at this topology drawing, our protocols and our network media let us know that we were going to have to use some type of gateway device. And we always recommend Tridium's Vicon. And you may say, well, why Tridium's Vicon? The way I see Tridium's Vicon, I look at it as a blank canvas, right? It's the purest form of Niagara in a JACE out there. So it doesn't have any manufacturer's embedded software tools on top of it. So anyone who's Niagara certified, any contractor or systems integrator who's Niagara certified can work on the Vicon JACE, right? But any Niagara certified contractor can't work on some of the other manufacturers' JACE because they have those embedded software tools. This is all part of that conversation we were having about open systems. Now, even though you've got a combination of IP, which is the lighting control in this H&V unit, the fire alarm panel, we've got MSTP out here in these VAV boxes, then you've got Modbus with those emergency generators. So this is what the segment drawing would look like. And there we go, back to our topology drawing. So when you're laying out an OT network, there's several steps to it, but as long as you understand the hardware that's involved, the cybersecurity concerns that are there if you're connecting remotely, and if the owner does tell you that, hey, we still want to see this stuff on our network, then you're only connecting in one place, and they can manage the VPN connections and all that good stuff. But the integration, the integrated systems out here in the building, those all sit on one network, your OT network. So if you guys have any questions outside of the information from the PowerPoint that's going to be made available, the recording and the PDF version of this presentation, you can always reach out to me. I can help you develop a Division 23 or Division 25 specification. Cochrane is launching a smartbuildingdesign.com website that's going to have a ton of information on there, from best practices to a ton of topology drawings, specifications, guides, specifications. And we also do topology drawings for engineers. I'm working on a few drawings right now to help a couple consultants lay out a few jobs. So here's my information. My email address is gfitzpatrick@cochranesupply.com. I hope this was helpful. Like I said, we had to do this like speed dating. I had to run through it pretty quick, but I hope this was helpful.
Well, we actually have a bunch of questions for you, Greg. So I'll start off if you want to open your Q&A one, or I can read them off to you here. We've got some queued up. Can you explain the difference between an OT network and an IDL network architecture, and how each would be specified differently? Now, some of these may get long and you might want to answer offline, but I'll give you that one to start.
Yeah, this is one I would like to answer offline. One of the things that I will tell you is that at Cochrane, we have a large IT group. And one thing that ends up being their pet peeve is when Greg Fitzpatrick tries to act like a cybersecurity or IT professional. So
Okay.
please, yeah, so please reach out. Yeah, I like to get my IT guys involved.
Okay, and before I get on to some of the other questions, I just want to remind anybody that's attending here is that we did have a prior session on cybersecurity specifications and networks, and we have hardening guides. There was an integration matrix. Greg showed an example of some documents of that in his slides, and we have a downloadable systems integration, master systems integrator matrix for those responsibilities that's also available to download from our website at tridium.com. Learn by role specifier. There's specifier page with documents there, as well as design guides for Division 25. So second question, can you explain how to specify a zero trust OT network? And this may fall in your same lines of your first question there.
Actually, it is. Yeah, these are two questions that I would love to have my IT group involved in when we have these conversations. That what is it, Danielle?
All right. So let's get to the third one here. I'm looking for a specification example specific to an OT network, not necessarily cyber, but can include that as well. So that sounds like the OT spec that you've got might answer that question. And if there's something that you can share, we can certainly post it up here as well for you. Next one, can you demonstrate how to specify different types of port security? I know you talked a little bit about locking the ports and software locking and physically locking. He says some clients will allow a dedicated switch port for each IP device, but some will not and may want the daisy chain devices. So, and I know you addressed a little bit of that. So,
yeah, and that's something that I would like to have offline also, because I just did a project where the owner wanted everything home run, right? They didn't want to daisy chain any devices, so they want the home run. So we had to use some special hardware for that.
Okay.
So I would love, I would love for him to shoot me an email. I can send you a sample drawing. I can send you a sample drawing and dig into it a little more.
Yep. And the next one, I mean, really comes down to a lot of things that we talk about with Niagara. Since there are many devices that are still serially connected. So a lot of stuff out there is not IP. So how are you specifying systems that cannot take a no 485 approach? VFDs, for example, are typically serial, as you mentioned. So yeah, indeed. I mean, and then you get into a lot of security capabilities with with Niagara dealing with that, but you wouldn't have that downstream. So are you having to deal with
Absolutely.
that? You know, do you put
Well, it goes back to the topology drawing that I just showed. That was a combination of IP and BACnet MSTP, right? So you're going to have to use your gateway devices, and that's what that topology drawing is for, to show how that system is laid out when you're using a combination of IP and MSTP, and you're still using 485.
Okay.
So
Next
you
one
would
is
use a gateway device. Yeah.
okay. Are you specifying a vetting process for clients' IT group to review and approve each device before connecting to their network? And then subsequent to that, would you be requiring third-party pen test results from those devices?
Yes, I know we're doing that. Our IT group was just involved in that. I just saw one of the guys filling out a questionnaire from a client regarding that. We work with Ford Motor Company quite a bit, where they made sure that their IT group vetted actually Niagara, in addition to a few other things, right? So absolutely.
Okay.
Yeah, and we are not using third-party penetration testing results. We let the client handle that if in fact they want to get into it.
Okay. Well, if that's all, I think I don't see any more coming in here. Oh, wait. Are you developing a 2805 11 specs?
Currently, no.
Okay. All righty. If that's it, I think, Richard, we have a number of questions for you. I think we can try to get you connected with Greg to speak offline. There's some very lengthy pieces there, and talk about his specs as well to work for you. For everybody else, thank you very much for your time and for attending. And again, the session recording will be available, as well as a PDF of the slides. It will be available as soon as possible. It might take us a day or two getting everything processed and up on our site. Thank you for attending our series, and we look forward to having you join us next spring when we start up again. And if you have any suggestions for the kind of content or depth you would like to see, please let us know. We will be reaching out for your feedback. Thank you. Have a great day.